This video is for class 9 physics, and in this video we are discussing about relative density and its measurement by Archimedes principle, right? So relative density, I think you are done in class 8 if you remember. You have done Archimedes principle, sorry, just before this video, okay, and density you have done in class 7. So I don't think so it will be quite difficult for you to discuss these topics. So let us begin. So coming to the first part, which is density, right, which is density. Now if equal volumes of different substances such as wood, iron, zinc, water, glycerin, mercury, etc. are weighed by a physical balance, we find that their masses are different. Obviously their masses should be different, right? The mass of iron is much more than the mass of equal volume of wood. This is because the particles of iron are heavier and more closely packed than those of wood, which you have studied in class 7 also. In other words, iron is denser than wood. Obviously the iron will be denser than wood. In similar manner, if we take equal masses, now we are taking equal masses of different substances like cotton, okay, lead, say 1 kilogram each, we notice that their volumes are different. Obviously cotton will be much huge compared to lead if we take same mass of each. Now the volume of cotton is much larger than the volume of an equal mass of lead. This is because the particles of lead are closely packed while those of cotton are very loose. In other words, lead is denser than cotton. Thus, to explain that equal volumes of different substances have different masses, or equal masses of different substances have different volumes, we use the term called density. So what is density? How it is defined? Now the definition of density will be: the density of a substance is its mass per unit volume. That is, density of substance can be written as mass by volume. So density can be written as mass by volume here, right? So let us go to the next column. Density is a scalar quantity. And it is represented by a letter rho or small d. If mass of substance is capital M and its volume is capital V, then its density can be written in this format, right? Unit of density should be, right, unit of mass divided by unit of volume. So that can be written as unit of mass is kilogram, as you all know, and the unit of volume is meter cube if we want to talk about SI system. So in SI system, unit of mass is kilogram and the unit of volume is meter cube. So the SI unit of density will be kilogram per meter cube. In CGS system, unit of mass is gram and the unit of volume is centimeter cube. So in the CGS system, the unit of density shall be gram per centimeter cube. Here, gram per centimeter cube. Now relationship between the SI and the CGS units, these things also you have done in class 7 and class 8 as well. Now here we can see 1 kilogram per meter cube. 1 kilogram per meter cube can be written as 1 kilogram upon 1 meter cube. Now as you all know, 1 kilogram has 1000 grams and 1 meter cube has 100 centimeter cube. So if we cancel this, we shall get 1 upon 1000 gram per centimeter cube. It comes from here 1000 upon, so its 100 cube should be 100 multiplied by 100 and then multiplied by 100. So these 3 zeros gets cancelled here, right? Now this is gram, this is centimeter cube. So if we solve this here, we shall get 1 upon 1000. 1 0 2 0 and 3 zeros here. Okay, so it is 1 upon 1000 gram per centimeter cube. Thus 1 kilogram per meter cube will have 1 upon 1000, which is 10 to the power minus 3 gram per centimeter cube, whereas if I reverse this here, so 1 gram per centimeter cube will be having 1000 kilogram per meter cube. Okay, so further going through the topic, example, the mass of 1 centimeter cube of iron is 7.8 gram, right? Hence the density of iron will be 7.8 gram per centimeter cube, or 7800 kilogram per meter cube. So different substances have different densities. Obviously different substance will have different density because the molecular arrangement is different. Effect of temperature on density. So most of the substances expand on heating, right, and contract on cooling. We have studied this in class 8 and in class 7 also, but their mass remains unchanged because the number of particles will not change. Therefore density of most of the substances decreases with the increase in temperature. As the volume increases, density decreases because the density is inversely proportional to volume. So density of most of the substances decreases with the increase in temperature and increases with the decrease in temperature and increases with the decrease in temperature. There is one exception also. The exception is water. The behavior of water is, however, very different due to its uneven expansion. Water, when cooled from a high temperature, contracts up to 4 degrees Celsius. Thereafter it expands below 4 degrees Celsius up to 0 degree Celsius. Thus the density of water gradually increases when it is cooled up to 4 degrees Celsius and then starts decreasing when it is further cooled below 4 degrees Celsius up to 0 degrees Celsius. So at 4 degrees Celsius the density of water is maximum. So at 4 degrees Celsius the density of water is maximum. Now because above 4 degrees Celsius again the density starts decreasing. That is known as anomalous expansion of water, which we shall discuss in the next chapter. Now the density of water is maximum at 4 degrees Celsius, equal to 1 gram per centimeter cube or 1000 kilogram per meter cube. So this much for this video. Thank you so much.